Okay, continuing on where we left off now, let's look at quadrant 3. So in quadrant 3, regardless of where the terminal arm is located, and any point that I choose on that terminal arm, the x-coordinate will be negative, and the y-coordinate will also be negative. So again, looking at the formulas for the three ratios, if x and y are both negative, and remembering that r will always be positive, the only ratio here that will end up to be positive is tangent, because tan theta is defined as y over x, and if those are both negative values, that of course would simplify to a positive. So in quadrant 3, only tangent is positive. So we'll mark that with a T. And lastly, in quadrant 4, for any terminal arm located in quadrant 4, and any point on that terminal arm, x will be positive and y will be negative. So if x is positive and y is negative, then the only ratio that will be positive in this quadrant is cosine. And so we'll mark that off with a C. And now you can see where the cast rule comes from. The cast rule tells you which ratios are positive in each quadrant. And so you can see that we've spelled out the letters C, A, S, T, beginning in quadrant 4 and working counterclockwise around through the quadrants. So let's just make one final note here to say the cast rule tells us which ratios are positive in each quadrant. Okay, moving on. The next question says, use special triangles and the cast rule to find the exact value without using a calculator. Okay, so the first one is sine of 225 degrees. So 225 degrees has a terminal arm right about here. And I know that because if I start on the positive x-axis, as I always do, and rotate counterclockwise, to the negative x-axis would be 180 degrees, and I want to continue 45 degrees past there. So there I have an angle of 225 degrees. So the terminal arm for 225 degrees is in quadrant 3. The reference angle for this angle is 45 degrees. It would be this acute angle between the terminal arm and the negative x-axis. So the reference angle is 45 degrees. There we go. Now, why is that important? Well, that's important because related angles have the same trig ratios, except the sign may be different depending on which quadrant we're working in. So let's remember from our special triangles that the exact value for sine 45 degrees is 1 over root 2. Now, since we are in quadrant 3, though, only the tangent ratio is positive in quadrant 3. the sine ratio is negative. In quadrant 3, sine is negative. So therefore, the exact value for sine 225 degrees will be negative 1 over root 2. Okay, and the next one asks us to find the exact value for cosine 330 degrees. So we're going to go through the same process here. So 330 degrees has its terminal arm in quadrant 4. So 330 degrees would be right about there. So the reference angle in this case will be 30 degrees. Will be this acute angle right in here. So the reference angle is 30 degrees. And remember, the exact value for cosine 30 degrees is root 3 over 2. So the cosine ratio for 330 degrees will also be root 3 over 2. We just have to decide if it's going to be positive or negative. 330 degrees has its terminal arm in quadrant 4. And in quadrant 4, cosine is in fact positive. So therefore, the exact value for cosine 330 degrees is positive root 3 over 2. And that concludes this lesson.